Next, let's look at a definite integral involving substitution. So you can see in this one, it would make sense to let w equal x cubed minus 4, right? That's the inside function to this fifth power. And then dw is equal to 3x squared dx. Okay, now we have 6x squared. So let's say 2 dw is equal to 6x squared dx. Okay, now there's a couple of different things we can do here. We could go ahead and calculate the antiderivative, not with the indefinite integral of this function, or we could transform the limits of integration. So what I'm going to do is I'll show you both ways. I'm going to first of all show you how to transform the limits of integration so that you don't have to go back to x. You can leave everything in terms of w. So all you need to do though is just, so whenever x equals 0, right, so that's our lower limit of integration, I'm just going to plug it up into back into this formula for w. So if x equals 0, then w equals minus 4. And if x is equal to 2, which is our upper limit of integration of our original integral, and when x is 2, this becomes 2 cubed, which is 8, minus 4, which is positive 4. Okay, so what we can do is we can just integrate this from minus 4 to 4 now, instead of from 0 to 2. And now when we do our substitution, we end up with w to the 5th times 2 dw. Okay, and so what do we get there? We get w to the 6th over 6, but then we have, don't forget, that's times 2. And then we want to evaluate that from -4 to 4. Okay, so let's see. So that's essentially w to the 6th over 3. So we're going to get 4 to the 6th over 3 minus, again we have w over 3. So it's basically minus 4 to the 6th over 3. And, because this 6th power is even, -4 to the 6th is the same as 4 to the 6th. So what we'll end up with is 0. All right. Now, you don't have to transform the limits of integration. If you don't transform the limits of integration, then essentially what you're doing, this is your antiderivative, and then you want to then substitute the expression for w in terms of x, right? So we end up with, essentially, we could write this as 1/3, and it's w to the 6th, right? So it's x cubed minus 4 to the 6th, and we want to evaluate that using the original limits of integration. Okay, we'll actually put a little line here just to make sure that you recognize that we're just doing this a different way. So this is just a different way of doing it. So, or you could do it this way, right? You could put w back in and not transform the limits of integration. So what are we going to end up with? We end up with 1/3 8 minus 4 to the 6th, and then minus 1/3 0 minus 4 to the 6th. Okay, so it's essentially the same thing. We get 4 to the 6th over 3 minus 4 to the 6th over 3, which is 0. Okay, so that's how we deal with definite integrals when we have substitution involved.